into lesson 26 today. We're going to be using our calculator to help us discover a couple of derivatives that are very challenging, if not impossible to do by hand. Yesterday we looked at the first one, just to review what that one was, the derivative of e to the x. Once we got to the end of our lesson yesterday, Amelia, what did we notice was true about the derivative of e to the x? It was the same. The derivative of e to the x was e to the x. Once we finally got our calculator to show us those two different columns, we saw that the y1 and the y2 had the exact same columns. One was the original function, one was the derivative. So this is one of the functions that we have in math. There's very few of them where the answer for the derivative is the same as the original function on your question. Today what we're going to be exploring is the derivative of ln x. Again, there is a relationship between ln and between e. ln is called the natural logarithm. It's a log that has a base of e on your question. We're going to attempt to do the same thing. We're going to look at some things about the chart that we're going to set up here in a few minutes to make sure that, okay, what's going on between the x values we're using, between what we get for the answer of our question. All right, let's see if we can do this correctly today. If you will please enter on your calculator, go ahead and hit the Y button. So that Y equals up at the top. Clear out anything that you already had in there from yesterday. So you probably have the two functions in there with your E functions. So on your Y equals button, clear out anything that you have. And for the Y1, we're going to enter the following function. Your ln button is over there on the left-hand side. It's the third up from the bottom. And remember to find that h, we need to use the alpha h in your question. Also, don't forget on your question, you need to put the entire numerator inside parentheses. So you need to start with parentheses and then the ln with another parenthesis to make sure that the entire thing is going to be divided by h. Okay, so start with a parenthesis. Enter what you see up there on the screen, making sure you close parentheses after everything I have up there, plus close the parenthesis after you finish entering the entire numerator of that question. All right, so if you've entered it correctly, your screen should look like this. So don't forget the parentheses around the entire numerator and then the parentheses like we're on the original question. Okay, everyone at that point of the question so far. Everyone good? All right, go ahead and hit second quit. So we're back on the main home screen, and this is where we made our mistake yesterday on our question here. We want to go ahead and set the h value just to make sure that our calculator does still have that h value of 0.0001. If you will type in that decimal number for me, your 0.00001, and then you hit the stow key, and that's the second one from the bottom on the calculator, and that was alpha h, and then hit enter. So it actually stores that number in for the h. That's where we made our mistake yesterday. We forgot to hit enter, so it would actually put that onto your calculator. Okay, so after you hit enter off to the side, it should say something like 1e to the negative 5 or something like that. Everyone's calculators say that at this point. Fantastic. Okay, go to your table setup key just to make sure that that is set up the same as yesterday. So if you'll hit your blue second key and then table setup is above window. Just double check that your table start as well as your delta table is still set at 1. They should be there because that's what we did yesterday. And if that is the case, then go ahead and hit the second key again, your blue key, and then your table, which is above the word graph. All right, as you're looking at your table here, and let me draw something up here on the board, because I want to go ahead and compare something here. So you have your x column, and it says the x column is 1, 2, 3, 4, 5. I'm just going to put the first couple up here. And then we had our y1. So the x is what we set on that table set that we wanted to start at 1. And then the delta table is what we wanted to keep counting by 1 in the question. The y numbers that we have are 1, 0.5, 0.3333, 0.25, 0.2, and there's a couple more that show up on your screen as well. The x is the x's that are being used on the function. The y function is the derivative, because that was the derivative formula when it said ln parenthesis x plus h minus the original function all over h. We have h approaching 0 because we have to do a limit when we were doing a derivative, and we have that h approaching a very small decimal. What I need us to notice here is the comparison between these two different columns. Yesterday, we noticed between the y1 and the y2 columns, they were exactly the same. That's why the derivative of e to the x was e to the x. Now, we don't have a y2 column this time because we didn't enter the original logarithm function. All that we entered was the derivative function. Any comparison that you guys recognize between the x column and its corresponding number in the y column? So maybe if we did this, it would help us. What is 0.5 as a fraction? 1/2. What is 0.3 repeating as a fraction? 1/3. What's 0.25? 1/4. What's 0.2? 1/5. Okay, so maybe that will help us now in the question. Do we see any comparison between the x's that are used and what we're getting on the y1 column? They are the reciprocals. So 1, if I flip it upside down, well, that's still 1. 2, if I flip it upside down, 1/2. 3, 1/3. 4, 1/4. And then 5, 1/5. So the pattern that we're noticing here, go ahead and mark this down in your notebook. The pattern that we're noticing for the ln function, the values of my y1 are the reciprocals of the corresponding values for x. Well, what did we put in for the y1 function? The y1 function was the derivative function. Again, the derivative formula says to take the original function, replace it with x plus delta x, but we're using h on our calculator, subtract the original function, well, that's what we did in the numerator, and then we're dividing either by delta x, but again, we're using h on our question here. So we've noticed that the y1 are all of the x's flipped upside down. They are the reciprocals of the question. Again, how does that help me? Because the y1 function was the derivative function. So what have we already seen about the derivative of our natural logarithm question? The derivative of ln x equals 1 over x. Okay, so how does that help me? In a few minutes, we're going to do a question like this, where it might say that the original function is 2x squared plus ln x. Our job is to find the derivative. We know how to do the derivative of 2x squared. Anna, what would be the derivative of 2x squared? 4x. It would be 4x. That's where we drop the exponent down to the front, multiply them together, and then take 1 out of the exponent. Well, here's the new part for today where it has an ln x. What do I know about the derivative of this natural logarithm? The derivative is 1 over x. Again, that's one that we'll just kind of have to remember and to memorize here. The 6th states are in the question, and the derivative of my natural logarithm question is 1 over x. To finish up the question, you just need to multiply those together, and you would say 4x over 6 plus x. That would be your final answer for the derivative function of the original problem that was given to you on your question. Okay, everyone with me so far as to what we're noticing about the logarithm function, about its derivative? So from the calculator, we saw that they were reciprocals. So I take whatever's sitting there for the x, I flip it upside down. That gives me what I'm going to put in for the derivative of my natural logarithm question. All right, now here's where I want us to notice something about our book from page 147. On page 147, they have graphed for us the natural logarithm with an absolute value of x. Now, that means on the right-hand side of the function, I would have the positive values for x. On the left-hand side of the graph, I have the different negative values for x. We know our definition of slope is rise over run. Go ahead and look at the right-hand side of the function where the x is equal to 2. You guys all see the dot there where x equals 2. Now, what is the slope where x equals 2? At the value x equals 2, Josiah, how many spaces did they go up? 1. And then how many spaces to the right did they go? 2. They went 2. So what is the slope? Again, the slope is the derivative. So when x equals 2, the slope that we had for rise over run was 1 over 2. Well, that makes sense because we just looked at the natural logarithm question. Its derivative, which is the slope, that was the definition of derivative, was the reciprocal. If my x value is 2, its derivative is 1 over 2. Now, let's look at a second situation that we see on the graph, which is where x is negative 2 on the question. Amelia, where x is negative 2, how many spaces up did they go? 1. They went 1 up, and then how many to the left did they go? 2. So what would you tell me there, Amelia, for the slope at the negative 2? It would be negative 1 over 2. So they went up, which is in the positive direction, but they went left, which is in the negative direction. So I just put the negative up there in the numerator. Again, that makes sense based on what we just talked about for the natural logarithm question, because its derivative, again, the definition of derivative is the slope. The derivative is the reciprocal. The reciprocal of negative 2 is negative 1/2. Okay, you guys with me so far about what we're noticing about our picture? Okay, and I kind of have some of this up here on the screen as well if you want to jot this down, or if you wrote down this, I think this is actually what I wrote on the screen. When this x was 2, we saw that the slope was 1/2. When x was negative 2, we saw that the slope was negative 1/2 on the question. Now, there's something that we have to remember, though, about logarithm questions. When we have a logarithm question, I'm just going to make up a different kind of question here. If I said log base 3 of x equals 2, how did we calculate what the x was on that question? Do you guys remember how to do those logarithm questions? It's been a while since we've done them.
Move the x to the front.
Okay, so it says x equals. So I'm not like swinging the x out to the front, that's not an exponent. There's log base 3 of x equals 2.
So then x, no. 2 to the third power.
Pardon?
2 to the third power?
Flip it around. 3 squared. Okay, didn't even listen to how I read it. Log base 3. Right. So that means the base of the exponent is the 3, and by definition, a logarithm is an exponent. So it is means equal. The exponent that I have is 2. All right, what's 3 squared? 9. Okay, let me show you this question. This is where I'm going to see if we can understand something. If I switch this number to negative 2 on the right-hand side of the question, well, if I want to calculate what x is, we need to switch it to exponential format. I don't have a logarithm on both sides that I can just ignore, so I do need to do that. So I have x equals, what does that look like in exponential format?
1 over 3 squared.
Okay, so originally it's 3 to the negative 2. A negative exponent flips something upside down. So you said 1 over 3 squared. And what's that equal to? 1 over 9. The two answers that I just got, are those two answers positive or are those two answers negative?
Positive.
They are positive. What we need to remember about a logarithm is the number that is sitting right here. It was called the argument of a logarithm. That argument is always a positive value on the question. You can never have a negative number sitting there in the question. That's what I was attempting to show you with these two different exponents. If I have a positive exponent, like I had on the left-hand side of the question, then we just treat it like a normal exponent. If I had a negative exponent, like I did on the right-hand side of the question, all that does is flip it upside down into a reciprocal on the question. There is no way to get a negative number behind a logarithm of our question. So how does that affect what we're doing today as we're looking at our natural logarithm on the question? Let me go ahead and skip past something. That's kind of what I just showed you there here. Let's see, is that what I wanted? Here we go. If I gave you this function, so go ahead and jot this down for me. Y equals ln x. Again, ln, this is the exact same question as me writing log base e of x. That's what the natural logarithm was. It was a logarithm that had a base of e. In this question, because the x is behind the logarithm, that x has to be a positive number, because I can only put positive numbers behind my logarithm. Okay, you guys with me what I'm trying to show you here? All right. Now, if I were to give you this function, y equals ln negative x. Now you may be thinking of, like, I thought you just said we can't have negative numbers behind the logarithm. Well, that's true. So what has to go in here for this x that would switch this to a positive number? It would have to be a negative number. So this function is only defined for negative values of x. So if I said x was negative 3, well then it says negative 3, which is positive 3. And I'm allowed to have a positive number behind the logarithm of the question. Now, this is an issue because I have two different kinds of problems here. One of them only works for positives, and one of them only works for negatives of a question. But how can I fix this so it works for anything that I were to put behind a logarithm? I would put an absolute value bar. What always happens when we do an absolute value in our question? It's always positive, and that will keep a positive behind the logarithm of your question. I can do the derivative if it just says ln x, if I only have a positive number. I can do the derivative of ln negative x only if I have a negative number for the x. But on this question with ln absolute value x, I can use anything that I want to for x. And that's what I want to be the case as we're talking about derivatives. I don't want to just limit myself to I can only use positives, I can only use negatives. It doesn't matter if I put a positive or a negative number in there for that x, because it's going to turn into a positive value when we do our absolute value bar in our question. Okay? There is only one thing I could not use on this question. And it's based on what we just looked at a few minutes ago about the derivative. What did we just notice was the derivative of our natural logarithm question? So what did we notice on our calculator?
That it was the reciprocal.
It was the reciprocal, so it was 1 over x. So whatever is sitting right here, that number went into the denominator of your function, whether that number is positive or negative. Because you can have a positive slope or you can have a negative slope on the question. What is then the only number I cannot use for x on that question?
0.
Why is it 0? You can't put a 0 into the denominator of your problem. So by putting this absolute value bar, I can do anything that I want to. It could be positive, it could be negative. It just cannot be 0 of our question. Okay? So again, I've got to have those absolute value bars. If I don't, I cannot correctly calculate the derivative for everything. I can only do the positives Or I can only do the negatives, but not both positives and negatives until I put in the absolute value bars of our question. All right, so just as a summary, then we're going to walk through two examples together here. So a summary of what we talked about. The derivative of e to the x is e to the x. That's the one that we saw yesterday. Again, that's one of the functions that we have in calculus where the derivative is the same as the original question. And then our summary for today. The derivative, if I have a natural logarithm question, it is the reciprocal. It is 1 over x in the question. Again, at this point, it does not matter if my x is positive or negative, because if I put a positive number back here, the absolute value positive is a positive. I can have a positive number behind a logarithm. If I were to put a negative number in for x, again, that's okay, because the absolute value of a negative is still a positive number, and that's what I would want to have behind the logarithm of your question. Again, as you're calculating the derivative, you would actually use the number that's in there for the x. So if I said the natural logarithm of the absolute value of -3, that derivative is -1 over thirds. Okay, so I'm not canceling out the negative for the final answer. I just need to make sure that what's behind the logarithm is positive, and that's what I'm doing as soon as I put those absolute value bars into my question. Okay. Any questions? Are we with me? Confused? Good? Not good? We're good? Okay, so let's see if we can correctly answer two questions together. And then I have a couple that we'll try out of our textbook as well as we're finishing up this morning. All right, so go ahead and copy this problem down for me. Let's see if we can correctly calculate its derivative. So these were like the questions that we did, I think it was lesson 25, where we have multiple pieces. When there's multiple pieces, we just do each one individually of the question. So our derivative notation is the derivative of y, because this is a y function, with respect to x, because there's x's that you have on the variable on the right-hand side. So that's all the notation means. The derivative of the y function with respect to x. All right, so the first piece, 4ln x. Okay, so that should send up something in my brain already, because that's one of the special functions that we just looked at. What is the derivative of ln x? So that's the one we just did today. It's the reciprocal. Okay, so this 4 that is in the front is still in the front. That is not what I'm doing the reciprocal of. I'm doing the reciprocal of what's behind the logarithm. What's behind the logarithm is just x. So I have 1 over x. Okay, we'll multiply that by the 4 in just a second. I have -6. I run into the next thing that says e to the x. Again, that should clue something automatically, because that's one of the special functions that we've talked about. What is the derivative of e to the x? It is e to the x. That's the one function that we've seen so far where the derivative is the same as the original question. Bring down your plus sign, and now we're at the last part, and that's the one we've already talked about before. Colin, what's the derivative of 2x squared?
It's 4x.
It is 4x. That's where we drop the exponent down, multiply, and then take one away, so I have 4x. Anna, can you go ahead and neaten up the final answer for me, please?
4 over x minus 6e to x plus 4x.
Very good. Now, before I switch to the next question, just to make sure that we understand something that I talked about a few minutes ago. Look at the ln part of your question. Does the ln part of our question contain an absolute value bar? No. What are the only kinds of numbers then that I'm allowed to use for x on this question?
1, 0, 0.
Okay, I can't use 0. And what else can I not use on this question, because there are not absolute value bars?
Negatives.
Why can I not use negatives?
You can't have a negative in front of the logarithm.
You can never have a negative behind the natural logarithm question because this x is just sitting there by itself without an absolute value bar. That tells me that those x's that I'm allowed to use in the question are only allowed to be positive values in the question. Because that x has to be positive, that's going to apply to everything that is in the question. Okay? As soon as I put the absolute value bars up there, which will be like my next question, then that means I can use anything. Because as soon as I put in an absolute value bar, absolute values already make things positive, which is the only kind of things that I'm allowed to put behind a logarithm of the question. So on this original function, I would not be allowed to calculate the derivative if they gave me a negative number for the x, because I cannot put a negative number behind a logarithm in my question. Okay, do you guys understand that concept there? Okay, so let's look at this function here. It's almost identical to the one that we just did. Y equals 4 natural logarithm of absolute value of x minus 6 e to the x plus 2x squared. As again, my job is to calculate the derivative. So the derivative of y with respect to x. We're going to go straight across the question and do each part individually. The 4 in the front, we just keep that number in the front. Amelia, what is the derivative of the natural logarithm of the absolute value of x?
1 over x.
It's still 1 over x. Anytime I see the natural logarithm, its derivative is the reciprocal. So 1 over x. Minus, I keep that 6. Josiah, what is the derivative of e to the x?
E to the x.
E to the x, that's the one where it was the same on the question. Anna, what's the derivative of 2x squared?
4x.
It is 4x. That's the one we've done before because the x is the base. We drop the exponent down to the front of our question. Colin, can you go ahead and neaten up that question for me?
4x minus 6 e to the x plus 4x.
Right, now you made me think, well, that's the exact same answer that we just wrote the last time, so why did I do that question again? Why is this question different than the first one that we just did on the previous slide?
Because the x has absolute value.
This one, the x has the absolute value bar. What does that now tell me about the x's on this question? Am I allowed to use positives for x?
Yes.
Can I use negatives for x?
Yes.
Yes, because those x's would land inside of the absolute value bar. That would turn them into positive numbers, and I can have a positive number behind the natural logarithm. What is the only thing I can't use for x?
0.
0, because I cannot put a 0 into the denominator when I go to do the reciprocal. So for this x, I can use both positives and negatives. I just cannot use 0 on the question. Okay, so if I were to give you this function and say calculate the derivative at x equals -3, you would be allowed to do it on this question, but not on the previous question, because of the absolute value bars being here, as opposed to the absolute value bars not being there on the previous problem. The formula at the end would be the same to get the derivative, but I can only use certain numbers for x on certain functions. Okay, you guys with me? Is it making sense what I'm hoping to tell you today? All right, so let's go ahead and look at